to record um, what we think is a first step for subsegmental. And so we're going to be starting with blood pools that look similar to this. And what we want to get to is left atrium, left ventricle, right atrium, and right ventricle. One of the things that we've discovered is the way the valves um, sit in the heart is that if I zoom in here, you can see how there's this concave nature to, so in other words, the left atrium, if this is the annular line here, the left atrium extends down in. And when you think about it, whenever the heart is squeezing and these papillary muscles are holding the mitral valve, it's called prolapse if it comes up above the line. So the natural state is going to be a concave nature here. And so based on how we perform our segmentations, in order to get a concave on the ventricular side, that means we need to be convex on the atrial side. So we really need to start with the atria. So if we kind of have this blood pool starting point, and then I can come in and just in by cutting out stuff, I can cut down and I can get to a point where let's see here. All I have is let's start with the left atrium. So, and left ventricle. So now I'm in a position here where I just have these two. And now to get to that convex where the so this is the left atrium up here, this is left ventricle down here, I can cut away and you can see that with the blood pool, we can see on the blood pool where that line resides, and then we just cut away at that. And what that looks like when we're done is this. And so this is a final result. And if you look up here, you can see where, what else is on? I guess on that. Here we go. So we can see how we're kind of just letting it come down into here because we want a degree of sort of natural state and consistency. And so that's sort of, so we'll, however you want to get there, left atrium and right atrium first. I actually find it easier to do the right atrium first, and then the ventricle, and then left atrium, and then the left ventricle. Also, I want to show you how I've left a little bit here to show you some of how we perform those cuts with this. So if I edit mask, all I'm doing here is removing. And so what I have pretty much is I took the right ventricle and right atrium that I'd created and I subtracted them through a Boolean operation. And then I subtracted that left atrium I just made. So what I'm left here is with a lot of this, including you can see the aortic valve coming out. And I want to show you. So I've got remove on. So all I'm going to do is cut up high, and I know nothing else is touching, so I can region grow. And now I'm dealing with just this last little bit. And a nice way we found to do the aortic valve and the pulmonary valve is to kind of look at it. You can see the cusp here, cusp here, cusp here. And so the way we're approaching this is if you angle, imagine a 45, and you just kind of cut all the way through it. And then you come around to the next iteration of that valve, which to get it angled about right. And now, like that, move it over. now I've got this last cusp here, and so I just want to get it so that no markers in the way, but kind of see through it. You can get it where I'm cutting right through that. Now, when you look at it, you can see how we've created that true, like the top of the left ventricular outflow tract. And you'll also notice that we now also have that. You can see that how we've kind of got an ice cream scoop shape down into the left atrium where that left ventricle is. And so this is how we're looking to generate those. Let me label this BP, LV, P, LV, second, just because we got we did the LV first time around, so we just wanted to designate this. But if I come back up and show, here's the right ventricle, right atrium, left ventricle, left atrium. This is the subsegmental blood pool, which is going to be our first step. So I just wanted to kind of get through this first step and give a quick show of how that is. And you'll notice, really, we should be able to perform all these tasks from just the binary mask in the 3D state rather than relying on the DICOM. That's the purpose here.